The Automatic Flight Control System, AFCS, includes the Flight Guidance Control System, FGCS, and Thrust Management System, TMS. The Flight Guidance Control System functions are Autopilot, Flight Director, Yaw Damper Turn Coordination. The Thrust Management System functions are Automatic Throttle, AT, Electronic Thrust Trim System, ETTS, Thrust Rating Selection, TRS. The AFCS system has the following components: Dual-channel guidance panel, 2 Autopilot quick disconnect switches, 2 TCS switches, 2 TOGA switches, 4 processing modules, single elevator servo, single aileron servo, and a single rudder servo. Pilot provides automatic flight path and roll control of the aircraft. The Autopilot performs the following functions: pitch attitude control via elevator commands for Autopilot stability computations, coupling to the vertical flight director modes, Autopilot pitch trim commands to alleviate elevator servo loads, roll attitude control via aileron for Autopilot stability computations, coupling to the lateral flight director modes. The Autopilot control limits for roll will be plus or minus 25 degrees, except in approach mode. In approach, the roll limits will be reduced linearly from plus or minus 25 degrees above 200 feet radio altitude to plus or minus 5 degrees at 0 feet radio altitude. The Autopilot will not command more than plus or minus 20 degrees pitch. The Autopilot function is selectable via the guidance panel. Engagement of the Autopilot will automatically activate automatic pitch trim function and the yaw damper turn coordination functions if not already active. Manual via the guidance panel push buttons or automatic, Autopilot, AP, FD system failure. Disengagement of the Autopilot shall not disengage the yaw damper. Manual or automatic disengagement of the Autopilot will disconnect the automatic pitch trim function. Failure of the yaw damper will not disengage or prohibit engagement of the Autopilot, provided the failure does not also affect the Autopilot flight director function. If no flight director modes are active, Autopilot engagement shall cause the FPA roll-hold flight director modes to activate. Note that Autopilot engagement is inhibited on the ground. The Autopilot has 2 channels, and one channel works as a hot spare channel. The system alternates the channels automatically if the active channel fails. The pilot can alternate the Autopilot channels manually on the Setup MCDU page. In case the Autopilot is deactivated, an aural alarm Autopilot is triggered.
Autopilot. Autopilot.
Pressing the Autopilot disconnect button manually disengages the Autopilot, and the annunciation on the FMA starts to flash for at least 5 seconds. The second press cancels the aural alarm and the visual information. In case the Autopilot is disengaged without using the Autopilot disconnect button, the Autopilot annunciation on the FMA also flashes for at least 5 seconds until the pilot presses the Autopilot disconnect button on the control wheel to acknowledge the disconnection. If the Autopilot is engaged and a failure in the Autopilot system occurs, the Autopilot annunciation on the FMA turns from green to red and flashes for 5 seconds, then becomes steady until the indication gets acknowledged and cleared by pressing the Autopilot disconnect button on the control wheel. The Autopilot shall disengage when the following conditions occur: Momentary switches for autopilot disconnect, touch control steering, TCS, and manual pitch trim are installed on both control wheels. The TCS function releases the autopilot clutches and resynchronizes the flight director. When the TCS button is released, the autopilot automatically re-engages the servos and resynchronizes the flight director. The autopilot trim function positions the horizontal stabilizer surface to offload the aerodynamic force held by the elevator to maintain a particular flight condition, hence the control column force maintained by the autopilot servo. A flight controls fault CAS message is generated if the trim control function becomes inoperative. The autopilot trim function activates only when one of the autopilot channels is engaged and manual trim is not active. The lateral guidance section of the guidance panel has the following function controls: approach button, APP, navigation button, NAV, low bank, automatic button, bank, heading button, HDG, heading select knob, HDG SEL, push to synchronize button, push sync, in the middle of heading select knob. The Mach trim is automatically functional when the following conditions are satisfied: autopilot not engaged, indicated airspeed above 0.7 Mach, manual trim of horizontal stabilizer not in progress, neither of the quick disconnect switches pressed, any other trim function is not commanding. The Mach trim is not functional if at least one of these conditions is not satisfied. It is also not functional if the Mach trim monitor detects a fault in trim rate command. Further, the Mach trim is not functional with autopilot engagement due to autopilot trim operation. The flight guidance control system indirectly drives the primary flight controls through either the cockpit control column or through other processing modules. The automatic flight control system function includes the automatic pilot, flight director guidance, yaw damper, turn coordination, and automatic pitch trim. Flight director guidance provides lateral, roll, and vertical, flight path angle, flight director modes, integrated with the FMS or manually commanded by the flight crew. Flight director guidance may be coupled or uncoupled to the autopilot. Turn coordination and yaw damping, Dutch roll damping, indirectly provide commands to the rudder control surface and function independently of the automatic pilot and flight guidance system. The automatic pitch trim capability is coupled to the autopilot and indirectly provides trim commands to the elevator control surface. The thrust management system consists of the electronic thrust trim system, thrust rating selection, and the automatic throttle. The electronic thrust trim system controls the fine-tuning of the automatic throttle, provides in-one command synchronization, and passes engine synchronization commands to the FADEC. The electronic thrust trim system is coupled to the automatic throttle. In other words, the electronic thrust trim system is disabled when the automatic throttle is disengaged. The thrust rating selection computes the active engine rating for the current phase of flight and for display on the ICUS. The thrust rating selection operates independently of the automatic throttle. The automatic throttle system automatically positions the throttle levers to control the airplane's thrust throughout the flight regime. The automatic throttle is fully integrated with the flight directory subsystem. However, it is independent of the autopilot engagement status. Integrated Guidance and Display Controller. The Integrated Guidance and Display Controller, also known as the Guidance Display Control Panel, GP, provides the means for selection or deselection of the following FGCS functions: lateral guidance, AFCS management, speed control, and vertical guidance. Flight director guidance, The Flight Director Guidance System computes flight guidance commands for presentation to the pilots on the Flight Mode Annunciator (FMA) section. The Flight Director commands selected on the guidance panel are computed using the PFD source. Only one vertical mode and one lateral mode may be active at a time. Up to 2 vertical modes and 1 lateral mode may be armed at one time. Modes are engaged via a push button and are disengaged by the successive push of the same button. Selecting FD off, labeled FD, on the guidance panel removes the Flight Director command bars from the non-coupled side of the PFD, if the automatic pilot is engaged. The lateral guidance section of the guidance panel has the following function controls: Approach button, APP. Navigation button, NAV. Low bank, automatic button, bank. Heading button, HDG. Heading select knob, HDG SEL. Push to synchronize button, push sync, in the middle of heading select knob. Push the approach button to arm the approach mode for CAT 1-2 as appropriate. Push the lateral navigation button to activate the lateral navigation mode. Push the low bank auto bank button to select the bank angle limit that will be used by the FGCS. The bank selection can be either a limit that is automatically selected, auto bank, or a fixed value, low bank. Push the heading button to activate the heading mode. The pre-selected heading target will become the active heading. Turn the heading select knob to manually select or pre-select the heading to be used for the FGCS. The heading select knob contains a push to sync button in the center. Press the button to synchronize the heading target automatically to the current aircraft heading. There are 2 course select knobs, one for the left PFD and one for the right PFD. The knobs are rotary switches that control left and right side course information and data selection. Each knob contains a center button that provides the ability to select the course, required to fly directly to the station. The Flight Guidance Control section of the guidance panel contains the following buttons: Autopilot Engage, Disengage button, the yaw damper button, and source button. If the autopilot is engaged, pressing this button causes the flight director to transition to the basic mode, roll FPA. If autopilot is not engaged when the transfer occurs, the flight director drops to standby mode and clears the flight director command queue along with the mode annunciation. The PFD data used by the FGCS and transferred by pressing SRC button includes Short-Range Navigation Source, VOR, Localizer 1, VOR, Localizer 2, Baro-Corrected Altitude, FMS Source, FMS 1, FMS 2. Speed controls. The speed control section of the guidance panel contains the following: the auto throttle engage-disengage button, the speed select knob, the indicated airspeed Mach push to change button located within the speed knob, and the manual FMS speed selector, which is also part of the speed knob. The automatic throttle button is used to arm and disengage the auto throttle. The automatic throttle annunciation will be displayed on the FMA when the auto throttle is engaged. The outer speed selector knob has 2 positions. The FMS position is used to select the FMS speed target. The manual position is used to activate the manual speed target. The inner speed selector knob is used for manual selection of the target speed along with the speed target bug. Turning the knob clockwise increases the speed, and turning the knob counterclockwise decreases the speed. The calibrated airspeed Mach push-to-change button is used to toggle between calibrated airspeed control and Mach control. The vertical guidance control section of the guidance panel contains the following functions: the altitude hold button, the vertical navigation button, the altitude select knob, the flight level change button, the vertical speed select wheel, the vertical speed button, the flight path angle button, and the flight path angle select knob. The VNAV button activates the interception and tracking of the vertical navigation path, according to the FMS request. The Alt selector knob selects the desired altitude. Clockwise rotation increases the altitude target, and counterclockwise rotation decreases the altitude target. A button in the center of the Alt Select selector knob provides the selected altitude to be displayed in meters above the normal Alt window and above the Alt Preselect window on the PFD. Push the altitude hold button to activate the altitude hold mode. Alt will be displayed on the FMA. If the altitude hold mode was active prior to the button activation, the altitude hold mode transitions to FPA mode. With FMS selected on the PFD as the primary navigation source, pushing the preview button on the display controller will cause the preview navigation source annunciation and the course select preview pointer associated with the selected nav frequency to be displayed on the PFD. The autopilot will then intercept the selected course while still displaying the FMS as the primary navigation source. To arm the approach modes, the approach button has to be pushed, and upon interception, the primary navigation source will change to localizer or back course instead of FMS. The Thrust Management System, TMS, is configured in a dual redundant architecture, designed for increased system availability. The system is comprised of the following dual components: auto throttle, AT, thrust rating selection, TRS, electronic thrust trim system, ETTS. Only one channel of the thrust management system, as well as only a single thrust rating selection, one electronic thrust trim system, and one auto throttle channel are operating at any given time. The pilot can select the priority auto throttle channel, as well as thrust rating selection and electronic thrust trim system channels via the MCDU. The auto throttle system controls the engine thrust by means of throttle movements to achieve the thrust rating received automatically from the FMS or as manually set on the guidance panel. The auto throttle system provides means to maintain the airplane within its thrust and speed envelopes. Thrust limiting is based on the active in-1 rating, while speed limiting is based on the low speed and maximum structural speed limits, VMO, MMO, gear, and flaps placard. Gust compensation is provided to increase the lower speed limit above 1.2 VS up to 5 knots in gusty conditions with slat flap position greater than 0. The auto throttle can be engaged on the ground when all parameters required are valid and auto throttle is capable. Auto throttle takeoff mode armed. Both thrust levers above 50 degrees thrust lever angle. In flight, the auto throttle can be engaged when all parameters required are valid and auto throttle is capable. Auto throttle button in the guidance panel is pressed. The airplane is above 400 feet above ground level. The auto throttle system has the following modes: speed control mode, speed on thrust, SPDT, flight level change thrust control mode, speed on elevator, SPDE, takeoff thrust control mode, go around thrust controlled mode, takeoff thrust hold mode, retard mode. Disconnection of auto throttle occurs when either auto throttle disconnect button on the thrust levers is pressed. Auto throttle button on the guidance panel is pressed. Thrust lever angle difference greater than 8 degrees. Auto throttle monitor tripped. The required system parameters become invalid. Transition to on-ground condition, weight on wheels or wheels spinning, and thrust levers at idle and auto throttle in retard mode. Pressing the AT disconnect button manually disconnects the auto throttle. Anytime the auto throttle is deactivated, an aural alarm, throttle, is triggered, and the auto throttle message on the FMA will flash for at least 5 seconds. Pressing the disconnect button a second time cancels the visual alarm and aural alarm, which sounds at least once. During an abnormal disconnection of the auto throttle, the aural alarm throttle is also triggered. A red auto throttle message on the FMA will start to flash, and an ICUS message will be displayed. Pressing the disconnect button will cancel the visual alarm and aural alarm, but the ICUS message will remain displayed. Speed control mode, speed on thrust, SPDT. In this mode, the thrust levers are commanded to provide a thrust rate as programmed to maintain the desired speed. The selected speed is controlled by engine thrust during climb, descend, and cruise phases. The vertical modes related to SPDT mode are Flight Path Angle, FPA, Basic Vertical Mode, Vertical Speed, VS, Glide Slope, GS, Altitude Hold, ALT, Altitude Select, ASEL, and the FMS function. Flight Level Change Thrust Control Mode, Speed on Elevator, SPDE. In this mode, the auto throttle maintains a fixed thrust setting, and the autopilot maintains the selected speed using the elevator command. For small flight level changes, FLCH mode, the auto throttle commands only the necessary thrust in order to maintain a comfortable predetermined schedule based on vertical speed. For large flight level changes, the auto throttle commands a setting at climb rating and descent in idle rating. The vertical modes related to SPDE mode are Flight Level Change, Overspeed, and the FMS function. Takeoff Thrust Control Mode. Takeoff Thrust Control Mode, TO, advances the thrust levers to the takeoff go-around position when auto throttle is engaged on the takeoff phase. Go-around thrust. The go-around thrust mode positions the thrust levers to the takeoff go-around position, providing the required go-around engine rating. Takeoff thrust hold control mode. Hold. The hold mode prevents undesirable movements of the thrust levers, causing thrust reductions during the takeoff phase. The hold mode activates when the takeoff mode is active and the indicated airspeed is greater than 60 knots. The auto throttle servos are then de-energized, and thrust lever movements are not commanded up to 400 feet above ground level. An ICUS message is displayed if the hold mode engages with the throttle lever angle position below takeoff go-around. The retard mode provides the retard of thrust levers to the idle thrust position during airplane flare-on landing. Retard mode activates based on a radio altitude valid and less than 30 feet and the airplane in landing configuration. Once the airplane touches down, the auto throttle automatically disconnects. Limited Thrust, LIM. In case the selected vertical mode requires more or less engine thrust than that available for the thrust rating selected, limited thrust will be set. In this case, the auto throttle will not be able to maintain the selected speed for climbing or descending, and an amber limited thrust will be displayed on the FMA. Limited thrust is associated with speed on thrust mode. Override, OVRD. The auto throttle can be overridden by moving the thrust levers manually, causing no auto throttle disconnection. In this case, a green override is displayed on the FMA. The thrust levers return to the auto throttle commanded position after the override is discontinued. The auto throttle is disconnected only if the thrust lever is moved beyond the takeoff go-round position.
Throttle.
Auto throttle single engine operation. In case the FADEC detects an engine failure or engine shutdown, the auto throttle deactivates the respected thrust lever. The operating engine's thrust lever remains active for auto throttle operation. Reducing the thrust lever to simulate an engine failure will cause auto throttle disengagement due to thrust lever position split. TLA trim. The thrust lever angle trim has the following functions. Perform small thrust adjustments with limited authority. Reduces excessive thrust lever movements. Synchronizes in-one rotation speed, increasing comfort. The thrust lever angle trim is set to on whenever the auto throttle is engaged, but the TLA trim even works when the auto throttle is disconnected when thrust lever angle trim on the MCDU TRS page is set to on manually. Thrust rating selection, TRS. The thrust rating selection automatically determines the appropriate engine thrust rating according to the flight phase. The FADEC transmits the thrust rating and in-one values provided by the TRS for display on the ICUS. The thrust rating can also be manually selected via the TRS page on the MCDU, pressing TRS key. The following thrust ratings are transmitted by the TRS. Takeoff, go around, climb 1, climb 2, cruise, continuous. The automatic flight system has an auto rating type transition logic that controls the engine rating changes according to the flight phase, airplane configuration, and number of engines running. Takeoff is the engine thrust rating selection on ground, and it remains in takeoff mode while the airplane is below 400 feet above ground level. The change of engine thrust rating from takeoff to climb is set when the following conditions occur simultaneously. Any change in vertical mode is detected. Airplane altitude is above 400 feet above ground level. Both engines are running. Landing gears are retracted. If no change in vertical mode is detected, the engine thrust rating switches from takeoff to climb at 3,000 feet pressure altitude above field elevation. The active TRS flight phase is set to climb when the airplane is in the air and the altitude preselector is above the current baro altitude. During a one-engine inoperative condition, the engine thrust rating changes from takeoff to continuous at 3,000 feet pressure altitude above field elevation. The active TRS flight phase is set to cruise when the airplane is in the air and the baro altitude is between 100 feet above and 100 feet below pre-selected altitude for more than 90 seconds. The cabin pressure controller contains two identical control channels. In auto mode, one channel is in control and the other is in standby. The channel in control uses actual cabin pressure from the cabin pressure sensors and various data from other aircraft systems, such as ambient pressure, engine power signals, landing gear information, baro correction, landing field elevation, and cruise flight level to calculate the requested reference cabin pressure. In manual mode, both channels of the cabin pressure controller revert to standby mode. The outflow valve position can then be directly controlled by the pilots. Note: manual mode is differential pressure limited, but not cabin altitude limited, and no automatic cabin depressurization on ground is provided.